So this is a problem that gives you an equation that now has not just one variable in it, but several. Right? When we look at this equation, we have an unknown that we call k, we have an r, we have an s. We also have some other constants. We have a 5 and a 9. But the goal, what's being asked of you in this problem, is to solve for r. In other words, let's keep the end in mind here. Whatever work we do here, the goal of it should be to get the r by itself. So in the end, that's what our answer needs to look like. Our answer needs to tell us what is r. So r needs to be by itself alone on one side of this equation. So how do we make that happen? How do we get this r to be by itself? One of the things that makes this problem different from the kinds of equations we solved before is just the fact that we have more than one variable inside of this equation, which means that at the end of this process, we have to expect that those other letters, the k and the s, are not just going to disappear. They probably won't disappear magically. So we have to expect that our answer will have those other variables in it. So we expect there to be r's, not r's. We expect there to be s's, and we expect there to be k in our answer on the other side of the equation from r. So unlike the other linear equations in this module, which have answers that are just x equals a number, r equals a number, u equals a number, this is going to be r equals some variable expression that has s's and k's in it, most likely. So let's keep that goal in mind as we go forward with this. Other than that, though, that's really the only thing that makes this problem different from other problems that you would solve when you're solving a linear equation. Which means that all this philosophy and all the steps and the strategies remain the same. So with that in mind, if I'm trying to get this r by itself in this equation, what would you like to do first? Yeah.
We want to isolate the r, so I started by adding 9s to itself and then the other side of the equation.
Great. So you're thinking here about, let's find out if we can subtract or add something to make this r be more isolated. Right? This r has a bunch of stuff around it on the right-hand side. If we can get some of that stuff to move from the right-hand side to the left, then we'll have made some progress. So, thinking about subtraction and addition, you were looking at this subtraction sign right there, 5r minus 9s, and saying, well, we can undo that subtraction using addition. And so what you added to both sides was 9s. So this is where the process looks a little different than when you're just solving an equation with a single variable in it. Because what we're adding to both sides is not a number, but rather is a variable term, 9s. But the goal remains the same, that if I add 9s to both sides, as Gabby was just saying, then the minus 9s and the plus 9s are going to combine like terms to become 0s, which is 0, and hence it just disappears. And at the end of that process, on the right-hand side of my equation, the only thing I'm going to have left is 5r. What do I have on the left-hand side? K plus 9s, right. So what it looks like has happened is that that 9s has just moved from one side of the equation over to the other. But the nature of that moving is that we've added it to both sides. And now we're one step closer to our goal of getting the r alone. And all of our subtraction and addition that we can do is done now. What's the only operation left on the right-hand side of my equation? Say again? Right. The only operation left is the multiplication that's implicit in between the 5 and the r. So if I want to get rid of that, how do I do it? Divide by, say again?
The 5.
Yeah. I want to get the r by itself, so let's divide by the 5. If I divide by the 5 on the right-hand side, then the r is going to be alone, which is exactly what we want, which means that whatever we write here is going to be our final answer. So what do I need to do on the left-hand side? If I'm dividing by 5 on the right. divide by 5 on the left. And now here's a source of potential errors that I see happen sometimes when people work these problems. We're having to divide the entire left-hand side of this equation by 5. So do that. When you put your fraction bar in, make sure that that fraction bar extends under both of the terms on the left-hand side. K plus 9s all divided by 5. One of the common sources of error is that people will just, whether they're in a hurry or just not thinking about it, they'll accidentally only divide one of the terms by 5 instead of dividing all the terms by 5. But as long as you can navigate that choice, then actually all of our algebra work is done. And at that point, I would recommend walking away. So the answer that we would give to this problem is that r is equal to k plus 9s, all divided by 5. So all we had to do to solve this equation to get r alone is use the same steps we would have used if there was only one variable instead of 3. Reverse the order of operations. Look for opportunities to add or subtract to get rid of the arithmetic surrounding r, which we did by adding 9s to both sides. So that's the shift in mentality. What you add and subtract is likely to have variables in it in problems like this. What you multiply and divide by at the next step may also have variables in it. But the goal is still the same. Get that r by itself using this process of reversing the order of operations.